So, hello everyone. Good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department from IIT Kharagpur, and I'll be taking your live interactive session on the course Farm Machinery. This course is taught by Professor V.K. Tiwari, Director, IIT Kharagpur. And what we'll be doing in this particular session, that will be solving some of the objective type questions based on the previous week's content. Okay. So what I will be doing, I'll be posting some of the questions based on the previous week's content in front of you. Okay. And what you have to do, you have to just answer them in the comment section or in the chat box. So the very first question for the day is this one: to measure the actual speed of the 2WD tractor, the sensor is generally mounted on front wheel, left rear wheel, and right rear wheel, and both B and C. Okay, so just try to solve. Okay, the correct option would be A, front wheel. Okay, why is it so? Just try to look here. Okay, this is a particular sensor. Okay, which is proximity sensor, that is only being asked here regarding this. Okay, this proximity sensor is used to measure the rpm of a wheel. Okay, what it does, it emits infrared pulses. Okay, so here you can see there is a circular ring with the spikes. Okay, this particular spiked wheel, it tries to interfere, or it tries to cut the infrared rays flow. Okay, so that particular counting is done, and in a given period of time, like in 60 seconds, how many number of times that interference is happening. Okay, so that particular count gives us the actual rpm. And in this particular question, it is being asked that to measure the actual speed of the 2wd two-wheel drive tractor, you have to mount the proximity sensor either on front wheel or on the rear wheel. Okay, and or both B and C, both left rear wheel, right rear wheel, or only on front wheel. So the correct option would be front wheel. Why? Because in case we will be mounting on either of the rear wheel. Okay, in case of a 2WD tractor, the torque is being generated by the rear wheels only. So the driving wheels will generate some of the torque also. Okay, so in the process of generating torque, the soil tire interaction will happen, which will lead to slippage of the tractor. Okay, so as the tractor slippage will take place, what will happen, that the actual speed will decrease. Okay, but in case of the front wheels, the slippage is not happening, so the actual speed of the rear wheel will be the actual speed of the entire vehicle. Okay, the rear wheel, in case of the rear wheel, the actual speed will be somewhat deviated. Okay, from the actual speed of the vehicle. That is why we mount the proximity sensor on the rear wheel in case of a two-wheel drive tractor. Okay, here this particular study has been taken place at IIT Kharagpur only. I've given you the reference also. You can please read and try to understand what the researchers have done here. Okay, mounted the proximity sensor on both front wheels and rear wheels. Okay, then they have also mounted a magnetic pickup sensor for measuring the engine rpm. Okay, supporting structure is there, then discrete ferromagnetic elements are there. Okay, why these ferromagnetic elements are required? To obstruct the magnetic field of the magnetic pickup sensor, so it can give us the rpm reading. Okay, then see here, draft sensing units they have developed. Okay, several draft sensing units they have developed for top link, left link, and right link. Okay, you can see here, and then they have made the entire circuit diagram for this purpose. Okay, embedded digital display and warning system of the slip of the velocity ratio. Velocity ratio in case of active tillage implement, maybe it is rotavator. Okay, example of active tillage implement is rotavator. Okay, system of velocity ratio and wheel slip for tractor operative active tillage implement. Okay, this is the thing here. Yes, this particular circuit diagram they have made. Okay, LCD board is there. Then for getting the readings from load cells, they've used HX 711 module. Okay, Arduino Mega 2560 they have used. Okay, then LED LCD board they have used. Okay, then three particular LEDs they have used. Okay, they are red, yellow, and green. Okay, okay. Then one I2C converter would be used. PCF8754. Okay, this is the thing. For bridge communication, they must have used it. Okay, then this is the entire digital display and warning system. Here, battery is fitted, circuitry is there. Okay, this particular part is, as you can see here, this particular thing is battery. Yes, this particular thing is microcontroller Arduino Mega 2560. This is circuit diagram. Okay, no physical circuit. Okay, not just circuit diagram. And this particular one is the LCD board. Okay, this is regarding the different parts of the system which they have developed. Okay, this particular logic they have given. Okay, here you can see what is the logic of the entire program. Okay, initialize start, then initialization, then reading the engine RPM, then counting the number of pulses for 5 seconds, then calculating the RPM and velocity of the wheels, then calculating the slip, then reading the load cells, then reading the torque and RPM. Okay, from the torque transducer, then calculating the VR velocity ratio, calculating the average RPM torque draft, taking 150 samples. Okay, then after the 150 samples, here we go come to the decision part. Okay, slip it less than 25% and U by V ratio is between 3 and 4. Then blink green LED. Okay, if slip is greater than 25% and U by V ratio is between 3 and 4, then blink yellow LED. And if slip is less than 25% and U by V ratio is less than 3, or U by V ratio is greater than 4. Okay, then you have to bring the red LED along with the buzzer which you have to just put on. Okay, this is the end of the program and it will continuously run using the in the loop. Okay, this is the thing here. Then this particular is the entire display system. Here you can see slip is there, U by V ratio they are displaying, then torque they are displaying, then draft they are displaying. Okay, each of the features they have displayed and along with the appropriate LEDs. Okay, green, yellow, red. Yes, this is the thing here. Yes, to measure the actual speed of a 2WD or two-wheel drive tractor, sensor is generally mounted on the front wheel. Mounting sensor on the front wheel of the tractor is a common practice for measuring the actual speed. Placement allows sensor to directly capture the rotation and speed of the front wheel, which correlates closely with the forwards movement of the tractor. Okay. Tractors, especially two-wheel drive tractors, okay, rely on front wheels for steering and propulsion. So hence they are not generating the torque. There would be no difference in the actual speed of the tractor and actual speed of the wheel. Okay, that is why we are mounting sensor on the front wheel. Okay, this is the thing here. Yes. Coming to the next question, PTO power of a two-wheel drive tractor is equal to 60 to 70% of the bhp, brake horsepower of the engine 80 to 90% of the bhp, then 90 to 95% of the bhp, and 45 to 55% of the bhp. Okay, yes, try to solve. Yes, try to just solve. Okay, as you can see, the correct option would be 80 to 90% of the bhp of the engine. Why is it so? Because PTO is the most efficient power outlet of a tractor. Okay, it is directly connected with the engine. Okay, so this is the reason, and whatever the inefficiency is happening here is because of the uh, transmission losses. Okay, which happen while gears are getting turned out. Okay, from the main driving unit. This is the reason. Yes. Most accurate answer is 80 to 90% of the bhp of the engine. And more detailed explanation is as follows: PTO power versus the engine power. PTO shaft doesn't transfer 100%. No transmission system has been developed yet, which is 100% efficient. Okay, that is the highest theoretical efficiency. Yes, the engine's powers due to various factors. Okay, friction. Friction occurs in happening in gears, bearing, and other components with the drivetrain, along with the same power losses. In the tractor cutout model, which is present here at IIT Kharagpur, as well as I have seen it in FMTTI Budni. Okay, there you can see those gears, bearings, along with the entire drivetrain. Okay, yes. Then PTO efficiency. The PTO unit itself might have some internal inefficiencies that contribute to power loss. Okay. Yes. Auxiliary systems. Modern tractors divert a small amount of engine power to run auxiliary systems like the alternator or air conditioning, further reducing the available PTO power. This is the reason. Then typical PTO efficiency is between 80 to 90%. Yes, for modern PTO systems. Okay, and whatever the reasons of inefficiencies are that we have already covered. Okay, this means that for every 100 horsepower generated, 80 to 90 horsepower is available at the PTO shaft. Okay, yes, correct option would be this one: 80 to 90% of the BHP, and 60 to 70% is bit too low. 90 to 95% is overestimation, more optimistic estimation, and 45 to 55% is not the answer. And as you must be knowing, two-third of the power is available at drawbar power outlet, and 80 to 90% of the power is available at the PTO power, as the PTO power at the PTO shaft. Okay, this is the thing. Yes. Coming to the next question. Yes, try to solve. The type of strain gauge in which a resistance wire is stretched between two frames, one being the moving frame and the other the fixed one, is known as bonded strain gauge, unbounded strain gauge, then foil strain gauge, then photoelectric strain gauge. Okay, try to solve. What is the correct option according to you? Try to just solve. Yes. The correct option in this particular case would be unbounded strain gauge. Okay, let us look at the type of strain gauges in great detail in this particular coming few slides. Okay, see here, there is particular frame, two particular frames are there, frame P, frame Q is there, and this particular strain gauge is known as unbounded strain gauge. Okay, when a force is applied on the structure under the study, that is frame P and frame Q, frame P moves relative to frame Q. Okay, and due to this strain, gauge will change in length and the cross section, and the strain gauge gets strained. That is the thing here. The strain changes the resistance of the strain gauge, and this change in resistance of the strain gauge is measured using a Wheatstone bridge. Okay, this is the principle being asked in this particular question, that in which strain gauge two particular frames are there, and this would be the correct option, that is the unbounded strain gauge. Change in resistance when calibrated becomes a measure of the applied force, and change in the dimensions of the structure under study. Application of the unbounded strain gauge. Unbounded strain gauge is used in places where the gauge is to be detached and used again, because two particular frames are there, then the straining and recalibration will not take place. Okay, if the straining happens in the entire strain gauge system, okay, then we have to recalibrate the strain gauge, so that will not happen. Okay, in case of load cells also, and in case of various other gauges, we have to recalibrate. Okay, that particular thing we can avoid if we use this particular arrangement. Okay, yes, this is the thing. Then the range of the gauge is plus minus 0.515% of the strain. Okay, will give a very high accuracy in your case. Yes, this is the thing here. Then another one was bonded strain gauge. Okay, bonded strain gauge element consisting of metallic wire, etched foil, vacuum deposited film, or semiconductor bar is cemented to the strained surface. That you can see that a wire is there, okay, and the strain is directly getting transmitted to the wire itself. Okay, they are called so because they are attached to the elastic element surface. The most commonly used are the bonded resistance type strain gauges. They are primarily used for strain analysis. Okay, bonded resistance wire strain gauges resistance element is cemented to the base, which may be a thin sheet of paper or a thin sheet of bakelite or any Teflon is there. Bonded strain gauge is connected to the Wheatstone bridge, and directly we can measure the amount of the strain on the system. This is the thing here. Okay. Then another one was foil strain gauge. Okay. Another option was there, and this is also a particular type of strain gauge. Okay. It's an extension of the resistance wire strain gauge only. Okay. The strain is sensed with the help of a metal foil. Okay. The metal and alloys used for the foil are and wire are nichrome, constantan. Constantan is nickel plus copper. Okay. Earlier we used to have bulbs made from this particular constantan wire. Yes. Then isoelastic, nickel, chromium, then molybdenum, and nickel and platinum. Okay. Foil gauges have a much greater dissipation capacity than the wire bound gauges on account of their larger surface area. Okay, when you have to measure the pressure as well as the change in the temperature, then we use this type of foil strain gauges. Okay, for this reason, they may be used for higher operating temperature range. Also, the larger surface area of foil gauges leads to better the bonding. Okay, foil type strain gauge transducer types have similar characteristics to wire strain gauges. Okay, this is the thing. Gauge factors are uh, typically the same. Just 1 second, guys. Just 1 second. Yes, just a second. There was some disturbance from my side. I'm very sorry for that. Yes, I was telling you about the foil strain gauge. Okay, it's an extension of resistance wire strain gauge. Okay, strain is sensed with the help of metal foil Metals and alloys used for foil and wire are nichrome, constantan, elastic, isoelastic, nickel and platinum. Okay, this is the thing here. Then what happens? Foil gauges have much greater dissipation capacity than wire bound gauges on account of the your this particular thing. Okay, they are having a much greater dissipation capacity than wire bound wound gauges on account of their larger surface area for same volume. For this reason, they can be used for higher operating temperature range. Okay, this is the particular case here. Larger surface area of foil gauge leads to better bonding. Okay, this is the thing here. Surface area is large. Okay, first thing is this. Another thing is the sensing part. Okay, the higher area will contribute to higher this particular larger the dissipation area is, larger the sensing area is. Okay, so this particular attribute is important. You can sense the change in temperature also, you can sense the change in the pressure range also. Okay, it's a very strain selective material, sensitive material. Okay, yes, the advantage of foil type string gauge transducer types is that they can be fabricated on a large scale, and they can be fabricated on in any shape. Okay, foil can also be etched on a carrier. Etched foil gauge construction consists of first bonding a layer of strain sensitive material to a thin sheet of paper or bakelite. Portion of the metal to be used as the wire element is covered with appropriate masking material. Okay. The etching solution is then applied in the unit. Okay. Solution removes the portion of the metal which is not masked, leaving the desired grid structure. This is particular is the fabrication. How you can fabricate that particular foil strain gauge, how they are actually made. But the application part is very simple. You can change sense the temperature change as well as the pressure change over a large area. This is the particular application of the foil strain gauge. Okay. Then this method of construction enables etched foil strain gauges to be made thinner than comparable wire units. Okay, this characteristics together with the greater degree of flexibility allows the etched foil to be mounted in more remote and restricted places on a wide range of curved surfaces. Okay, on a wide range of curved surfaces, you can generally mount this particular foil strain gauge. Okay, this is the thing here, and you can sense what is the degree of flexibility, what is the change in pressure, what is the change in temperature. Okay, this is the thing here. Longitudinal sensitivity of the foil gauge is approximately 5% greater than that of the similar wire elements. Transverse strain sensitivity of this gauge is similar to 1/3 to 1/2 of similar wire gauges. Hysteresis is also 1/3 to 1/2 of wire strain gauge. This is the thing here. Resistance film formed is typically 0.2 mm thick. Resistance value of commercially available foil gauges is between 50 and 1000 ohm. Sense films are vacuum coated with ceramic film posited on plastic backing for insulation. This is the thing here. Yes. Another type of strain gauge very recently being used is photoelectric. Okay, photoelectric strain gauge. Okay. In this particular gauge, what is happening here that there is a sender. Okay, there is a source for light as well as there is a receiver for light, and as you can see the tubing, okay, where the light is traveling is directly just exposed to the strain. Okay, so what will happen, the intensity of light will change according to the strain applied. Okay, and that particular intensity of light is sensed and converted into electrical current. Okay, so as to measure the strain applied, obviously you have to perform some calibration. Okay, after the calibration that particular strain gauge is ready. Yes, this is the thing here. Okay, then piezoelectric strain gauge is there. Okay, as you know, the piezoelectric sensors, okay, they can generate electricity when subjected to strain or when they are subjected to some pressure. Piezoelectric sensor, they generate electric voltage when strain is applied over it. Then strain can be calculated from voltage. Okay, piezoelectric strain gauges are most sensitive and reliable devices. This is the thing here. Okay, what is happening here? That when strain is getting applied to that particular sensor, then in that case, what is happening? That is directly converted into my electricity. Okay, and that electricity voltage as well as the current that can be sensed, and that you can just see that what is the value of the strain. This is the thing here. You have to calibrate this particular sensor for strain versus electrical current. Okay, this is the thing here. Or not in if you want, you can just go for voltage also. Okay, whatever would be the whatever would be showing more deflection, that we will select. Okay, current sensing is tricky. Okay, for that you have to use a separate module, but voltage sensor, you can always sense using the voltage divider circuit. That is very simple to make. Okay, so you can go for voltage also, because that the spike in the voltage for uh, given amount of strain would be much larger. Okay, this is the thing here. Then detailed explanation I have written here. The type of the strain gauge in which a resistance wire is stretched between two frames, one frame being moving and other being fixed, is known as unbounded strain gauge. Okay, unbounded strain gauge consists of resistance wire, usually made of constantan or nichrome, that is stretched between two frames. One frame is stationary, other frame moves relative to the fixed frame due to strain or deformation in the material being measured. Okay, then operation I already told you, then application I have already told you. After the class, please download the PPT and see from here by yourself. Okay, then same for bonded strain gauge. Okay, application part is experimental stress analysis, structural monitoring, then load cell application as well as the other applications. Okay, this particular thing is there. Okay, see for yourself. This is the thing. Yes, description and operation already I have explained you. Then same regarding the foil strain gauges. Okay, application is precise strain measurement, including aerospace, automotive, and structural testing. Okay, yes, foil strain gauges are made for a very thin, flexible metal foil. Okay, Constantan or EMA. Okay, this is the thing here. Yes. Then similar to bonded strain gauge, when strain is applied to the material, the foil strain gauge deforms along with it, causing metal foil to stretch or compress. Okay, changes the resistance of the east foil pattern. Okay, this is the particular just description of foil strain gauge. Okay. Then regarding the photoelectric strain gauge, the last option was this only. I already explained you how it particularly works using the principle of optics. Photoelectric strain gauge utilizes optical principles rather than electrical resistance to measure the strain. I already told you that there is a light source. Another thing is there is a detector where the strain induced movement or deformation changes the amount of light reaching the detector. Okay. Then that change has to be converted again into electrical signal, and the current has to be measured or the voltage has to be measured. Okay. Photoelectric strain gauge can be used in environments where electric strain gauge may be impractical or sensitive to electromagnetic interference. Okay, used in many places. Okay, high temperature environments where traditional strain gauges may not survive. This is the thing here. Okay, yes. Please do try to solve this particular question. Next question for the day. During a test, the strain gauge with resistance of 250 ohm undergoes a change of zero point 0.2 ohm, and the strain of the gauge is 1.5 into 10 raised to power minus 4. What would be the gauge factor? Okay, if you don't know the formula, I'll just tell you. Okay, gauge factor. Gauge factor that is given by del R by R or del L by L. Okay, this is the thing. Please do try to solve. Change in resistance over the original resistance. Okay, and change in length over original length. Okay, denominator is directly given here. Just you have to put the values of del R and R. Okay, denominator directly you can just copy it down. Okay, do try to solve. I'll also solve along with you. No problem. Yes. What is the option which you are getting? Please do tell me. Del R is given here. Okay. Then R is given here. Okay. Del L by L directly you can provide as 1.5 into 10 raised to power minus 4. Okay. This is the thing.
Option B,
Option B 5 point.
Yes. Correct option would be 5.3 only. Okay. I also have just calculated. Okay. See here. You can see it, I think, in reverse, but no problem. It would be B only. Yes. Correct option would be 5.33. Why? Because everything is given here. Okay. Del G gauge factor is given. The symbol is G. Okay. G is del R over R divided by del L over L. Okay. Directly, we have been given del R change in resistance 0.2. Then upon R we have been given 250, and del L by L directly strain of the gauge. Okay, as given here as 1.5 into 10 raised to power minus 4. Keeping all the values, we will get G as 5.33. Yes. Next question. Which of the following forces in a 3-point linkage which system of a tractor can be measured using the Wheatstone bridge of the circuit, Wheatstone bridge circuit of the strain gauge configuration? Okay. So you have to just tell that which of the forces can be measured. Okay. Then bending force in lower link, then axial force in lower link, compressive force in the upper link, or all of these. Okay. Just tell me the correct option. Already it has been covered in, I think, in the 3-point H linkage. Okay. D. Good. Very good. It would be D only. Okay. All of these. Okay. Yes. See here. See for yourself. Okay. I'll just give you the correct explanation. All of these would be correct. Binding force in the lower link, axial force in the lower link, compressive force in the upper link. All can be measured using the Wheatstone bridge configuration. Okay. In the Wheatstone bridge strain gauge configuration. Okay. Entire thing is this particular. Uh, what is happening here? The strain gauges are fitted in a Wheatstone bridge configuration, and the strain is measured. How is it done? I'll just brief about it in the upcoming slides. Okay. See here first. The strain gauge are the excellent measuring tool for mechanical strain. They can uh, measure the deformation of the material under the stress, strategically attaching them to the specific points of the hitch components. We can measure the forces which are acting on them. Then Wheatstone bridge, as you must be knowing, it amplifies the small voltage change caused by the strain in the gauges, allowing for accurate measurement of the forces. And where you have to place these particular strain gauges, for measuring the bending force in the lower links, strain gauges on the outer surface of the lower links have to be attached. Okay. Then for measuring axial force in the lower links, the strain gauge has to be attached along the length of the lower link. Okay, this particular point is very very important. For measuring the axial force, you have to attach the strain gauge configuration along the length, and for measuring the bending force, you have to attach along the outer surface of the lower link. Okay. Then for measuring the compressive force in the upper link, okay, you have to attach the strain gauge, okay, on the upper link, and you can measure directly the compressive force which is exerted by the hydraulic ram to raise or lower the attached implement. Okay, this is important here. The properly designed Wheatstone bridge configuration and strain gauge Wheatstone bridge strain gauge configuration can measure all the forces which were given here. Okay, see for yourself. Here I have taken this particular research paper. Okay, here we have just fabricated a 3-point H dynamometer, okay, which can measure the entire forces of the 3-point H linkage. Okay, see here, 6 load cells are attached. Okay, I'll just mark them. First one here, then second one just behind it, third one, fourth one, fifth one, sixth one, and these particular 6 load cells can measure all the forces which were given here. Okay, what were the forces? The axial and the compressive force in the axial and the bending force in the lower link, and the compressive force in the upper link. Okay, it can be measured here using this 6 load cell configuration. Okay, how is it being done here? See here, the longitudinal, the load cell configuration has been given. The implement end frame is given. Okay, here you can attach the implement. I'll just show how practically it is done. See here, this particular load cell configuration we have made. Okay, then we have attached implement here. Here the implement which is attached is subsoiler. Okay, this particular implement is subsoiler. Okay, I'll just write it down for you. Yes, subsoiler. Yes. Okay, and aside of it is the calibration of different load cells as well as the programming, how we can measure the uh, different forces acting on the 3-point H linkage. Okay, this is the thing here. Yes, moving on to the next question. Please, if you are having any doubts in any question, please ask me. Okay. Next, we'll move forward. The metering device commonly used in mulch planters and doubling planters is pocket type metering device, vertical descending cup, rotary cup metering device, or D is conveyor type metering device. Try to answer. What would be the correct option? Please do try to answer. The metering device commonly used in mulch planters and doubling planters. Okay. Please do try to answer it. Pocket type metering device. Already it has been covered in the lecture. I have taken the snapshot also directly from the lecture only. Okay. Pocket type metering device, vertical descending cup, rotary cup metering device, conveyor type metering device. What would be the correct option? Okay. Yes, A. Pocket type metering device. Okay. No, the correct option would be vertical descending cup. Okay. I'll explain you. Here, this is the mulch planter. Okay. You can see for yourself the mulch planter which was being asked here. This particular mulch planter is developed by Indian Council of Agricultural Research. Okay. They have developed this particular mulch planter. Okay. Metering devices which are used for vegetable transplanting all were there. Okay. Pocket type metering device, then vertical descending cup is there, then rotary cup type metering device is there, then conveyor type metering device is there. Okay, all four are the different types of metering devices. Okay, first one is pocket type metering device, which is used in case of transplanting bare root seedlings. Okay, like the seedlings for eggplant, tomato, cabbage, okay, cauliflower, sweet potato. The other one was, which was being asked here, is was the type of metering mechanism used for mulch planter or for dibbling planters. Okay, that one is vertical descending cup or bucket type metering device. Here, I think it is not clear in this particular figure, but see for yourself. Okay, this particular configuration, the chain here, will just mark this particular chain, which you can see. Okay, it traverses this particular mechanism which transfers the mulch directly into the soil root zone. Okay, this is important here. Then another one was rotary cup type metering mechanism. It is used for pot seedling in semi-automatic transplanters. Okay, it can transplant up to 50 to 80 seedlings per minute in a row and used for tomato, cabbage, cauliflower, sweet potato. Another option was conveyor type metering device. Yeah, it is also used in case of semi-automatic and automatic transplantation. Okay. Yes, it can transplant 84 to 90 seedlings per minute in a row. And the option which was correct in this question is vertical descending cup or bucket type metering device. Okay, used for transplanting mulch or for dibbling transplanters. Okay, this is important here. The vertical descending cup metering device consists of vertically oriented cups that descend into the seed hopper filled with seeds. As the cup descends, they pick a specific amount of the seeds. In your case, it would be mulch. Okay, and then deliver them into the planting furrow or dibble. As I showed in the figure, the chain is attached. Okay, that will lower down this particular cupping mechanism, and it will plug down the metering device. Okay, it will plug down the seed. Okay, and it will directly transplant or directly sow them into the soil root zone. Okay, the descending motion of the cups is typically synchronized with the forward movement of the planter or transplanter. Synchronization ensures that seeds are dropped at regular intervals in a controlled manner, ensuring accurate seed placement and spacing. Advantages include include simplicity, reliability. Okay, and as you can see here, the mechanism is driven by chain, so torque transmission would be equal. Okay, slippage would be less. This is particular advantage, just for your kind information. Commonly used in planting operations where precise seed placement and spacing are critical, as in case of mulch and dibbling planters. Okay, vertical cup metering device is favored in mulch planters and dibbling transplanters due to its effective seed handling capabilities and reliability in delivering seeds uniformly. Okay, this one is the correct option. Okay. Yes. Moving to the next question. Please do try to solve this particular question. A two-wheel drive tractor with a traction wheel of 700 millimeter diameter was tested in test field at a forward speed of 0.5 meter per second. The angular speed of the wheel is 16 revolutions per minute. You have to calculate the wheel slip. Wheel slip is given by 1 minus theoretic actual velocity divided by theoretical velocity into 100. I'll just write down the formula. Okay. Yes. Slip is given by this particular formula, 1 minus actual velocity divided by theoretical velocity into 100. Okay, try to calculate. I think actual velocity you have been given, you have to calculate the theoretical velocity. Okay, yes. Please do calculate it. Try to calculate the slip. I am just coming in 2 minutes. Okay. Yes. What is the correct option? Okay. Let me proceed. Okay. See here, correct option would be 14.68. I'll just show you the entire calculation. Okay. Everything has been given here. The diameter of the wheel has been given here as 700 mm. Okay. This is given, I think. Speed has been given zero point 0.5. Then omega we have been given as yes. Okay, okay, okay. I'll wait. I'll wait. No problem. No problem. You try to calculate. No problem. I can wait 5 minutes. It's 402. I'll just don't say anything up to 407. Okay. Try to solve. Take your time. Yes, you got the answer as B. Good, very good. Yes, I'll also explain. Sorry, I didn't wait for you. Next time, be a more responsive. Just tell me I have to wait. I'll wait. Okay, no problem. Yes, diameter of the traction wheel is zero point 0.7 meters. Okay, then forward speed is zero point 0.5 meters per second. Then omega is 16 revolutions per minute. Then you must be knowing omega is in revolutions per minute. So I have to just uh no. It is N. It is RPM. Sorry for some mistake. Just a second, I'll just correct. It is N. Omega is not given here. Omega we have to calculate. It is RPM of the wheel. This is RPM, revolutions per minute of the wheel. Okay. Then omega is 2 pi n by 60. Okay. 2 pi by 60, it is there. Then directly multiplying 16 with it. Okay. It will give me 1.68 radians per second. Then theoretical velocity, which is given by omega into r. Okay. Always v equal to omega r. Simple relation is there. Then omega is provided here 1.68. Then r is d by 2. That is zero point 0.7 by 2. Okay. 0.588 meters per second. Then slip, I already told you 1 minus VA by VT into 100. Directly applying the formula, you will get 14.68%. No problems in this question. Okay. Yes. Moving to the next question. Okay, I think no doubt would be there. Just try to answer this question. To measure the torque of a rotating shaft, strain gauges are fixed to the shear planes on the opposite side of the shaft at an angle of 55 degree, 50 degree, 40 degree, or 45 degree.
Option D.
Option B, 50 degree. Okay, no, it won't be correct. It would be 45 degree. Why is it so? The strain gauge, as I already told in the my previous few questions, strain gauge converts the torque into the electrical signal. Sensor is bonded to a rotating shaft. It deforms when the torque is applied, and four strain gauges are attached to the rotating shaft in form of a Wheatstone bridge. Okay, and they have to be placed precisely at 45 degree with the shaft axis. Okay, with the shaft axis they should make an angle of 45 degree with gauge 1 and 3 being diametrically opposite. Okay, I'll just draw the configuration. There are no spaces there, that is why I've drawn here. This is the configuration. 1, then 3 and 4 that you have to make diametrically opposite. 1, 2, 3 and 4. Same configuration you have to just use. Okay, this is the configuration. Just a second. Yes, four strain gauges are attached to the rotating shaft in the form of a Wheatstone bridge circuit. Okay, that circuit you have to make precisely placed at 45 degree with the shaft axis. Okay, directly using the geometry, we can calculate that half of that 45 would be 90 only. Half of 90 would be 45 only. Okay, placed precisely at 45 degree with the shaft axis. Okay, with the gauge 1 and 3 they have to be diametrically opposite, and 3 and 4 uh, 2 and 4 they have to be diametrically opposite. I think I committed some mistake. uh 3 4 1 and 3. Okay, just a second, I'll erase this thing. Not problem. Just a second. Yeah, this will be the correct option, correct configuration. Sorry for the mistake. Yeah, I said B, sorry, D. Yeah, 45 degree. Yeah, no problem. Please be very careful. Even in the exam, you have to make sure that you are correct with the configuration. Okay. Yes. Where were we? Here. There we were at this place. If you face any difficulty in the seeing the slides, please inform me immediately. Although I'm viewing on the three screens, but okay. But possible that something goes out of my control. Okay. Yes. Here I was. I do the configuration 1, 2, 3, 4. Okay. And this one would be the correct. Yeah. And the angle would be 45-degree. Using a simple geometry, you can see. Okay. Torque is applied to the shaft. The shaft gets twisted to the direction of rotation, thereby producing some shear strain. Okay. It will cause elongation in the gauge 1 and 3, and it will simultaneously compress gauge 2 and 4. You can see from the geometry. Okay. Change in the strain gauge lead to an increase in the circuit resistance due to tensile strain generated by one pair of gauges, and a decrease in the circuit resistance due to the compression stress generated by other pair. Okay. Results in an unbalanced bridge which produces the electrical output corresponding to the applied torque. Okay. This is the thing. 45-degree angle to the longitudinal axis effectively measures the maximum shear strain which can occur due to the torque which is applied on the shaft. Okay. Torque applied to the shaft induces shear. Torque applied to the shaft induces shear stress and strain in the material. Placing strain gauges at 45-degree to the longitudinal axis, they are oriented optimally to measure the shear strain, and that would be most accurate. Okay, when you will use the Wheatstone bridge configuration. Okay. Moving to the next question. If you are having any doubts, please do ask me regarding any of the question. Okay, which were there in the previously also as well as current also. Okay, I am moving forward. Yes, please do try to solve this question. Very important. Okay, I have framed it just yesterday only. Okay, please do try to solve. Tractor is used to pull a plow through a field. Tractor has a weight of 50,000 newtons. Okay, and it is exerting a horizontal pulling force of 15,000 newton. Coefficient of rolling resistance, it has been given as 0.05, and you have to determine what is the engine power in HP if it is moving at a constant speed of 2 meters per second. Please do try to solve it. Simple question is there. Okay, net force multiplied by velocity. P is F into V. Simple physics. Okay. Do try to solve. It is 16:12. I'll not say anything up to 16:17. Okay, I'll give you 5 minutes time. Simple physics, you have to apply P equal to F into V, and net force you have to calculate. Then you have to multiply it with velocity. Okay. Okay, no problem. Yes. Then in that case, I'll just move forward. Okay. The correct option would be 47 HP. Okay. I'll just tell. Okay. First, you have to determine the rolling resistance force. Okay. I already gave you what is the coefficient of rolling resistance and what is the net weight. Okay. So just you have to calculate the rolling resistance that is given by mu r into W. First thing. Okay. Rolling resistance plus the horizontal pulling force, entire thing, sum of that multiplied by velocity will give me the power. And then I'll calculate it in HP by dividing by 746. Simple approach. Net force P equal to F into V. Okay. This is the formula. Yes. Now try to calculate. P has been given here. Oh, FR that you have to calculate, mu R has been given here. Okay, 0.05 multiplied by 50,000. That will give me 2500 newtons. First thing is I have calculated the rolling resistance. Then the pulling force. Pulling force that has been directly given here is 15,000. Then net force. Sum of these two forces 15,000 and 2500, that is 17,500. Okay. 17,500 Newton, that is the net force that you have to multiply it by the velocity. Velocity in our case is 2 meters per second, already given here. Okay. Yes. Then you just sum the both things and then you calculate what is the power. SI units I am using, then 17,500 Newton multiplied by 2 meters per second will give me 35,000 watts. Newton meter per second is also known as watt. Okay, 1 Newton into 1 meter per second. Yes. Then in HP, what would be the power requirement? That will be just dividing it by 746. When you will calculate, you will get 35,000 watts. Okay, 17.5 multiplied by 17.5 k watts multiplied by 2, 35,000 watts. 35,000 that divided by 746 is 47.46.91, and my correct option would be this one. Okay, 47 HP. Okay, important question from exam point of view. Please do revisit this question. Okay, after the class is over, just try to revisit the question as well as see the entire thing. Okay, for yourself, calculate once also. And the last question for the day would be this one. The ratio of change in output signal to the change in input signal is known as accuracy, resolution, precision, or sensitivity. Okay. The correct option would be sensitivity. Okay. The ratio of the change in the input signal, a change in the output signal to the change in input signal is known as sensitivity. Sensitivity is a measure of how much the output of a system or device change in response to given change in its input. It quantifies the responsiveness or the ability of a system to detect or respond to the changes in the input. Del O over I means, meaning is this: as my input is changing, how much change is there in the output signal? That is the sensitivity. Okay, change in the output signal to the change in input signal. And another option, the other attributes which were there were accuracy, resolution, precision, and accuracy refers how close a measurement is to the true value or the accepted value. Okay, minimization of the error. Resolution is the smallest change in the input that can result in a detectable change in the output of a system or the device. That is the resolution. And precision refers to the consistency or the repeatability of the measurement. Okay, means 10 times I'm performing an experiment and how close my values are coming. There might be error that we deal in accuracy, but the repeatability is dealt in precision. Okay, so sensitivity, this would be the correct option. Change in the output signal to the change in input signal. Okay, that's it for the today's session. Okay, thank you for joining. Okay, do join the session next week at the same time. Okay, I'll post the recordings as well as the uh, handout links. Okay, on this particular Google document. Okay, Google spreadsheet. From there, you can just uh, download and see for yourself. I'll also post the recording link. Okay, thank you for joining the session. Have a wonderful day. Do join the session next week at the same time. Thank you all.